Hi, alright, today I'm going to do a geometry lesson, which is over lateral area and surface area, which if you're using the Untitled Geometry book with sections 12.2 and 12.3, I'm going to combine them because they're about the same thing. So, and of course these formulas are found all over the place, and you may see them a little differently than how I have them presented right now. But we're talking about 3D shapes when we talk about lateral area and surface area. Okay, lateral area is, imagine if I had a container, for instance, if I had like this, a water bottle, and the lateral area is around it. Okay, it does not include the bases. Of course, I see an object I could probably use in my background, but imagine like a tissue box. Lateral area is around it, not the top and bottom of the tissue box. Imagine a cone. Lateral areas around it, not the top and bottom. So right now this is lateral area. So and we're talking about 3D shapes. For a prism we have L, which equals P, where P, and over here I guess I should write that. P is perimeter. Hope I spelled that right. Okay. And L is our lateral area. So if you want to associate this, that's our lateral area. Okay, and h is our height. That is our distance between the bases. So h, height, and then add a little distance between bases. That's the best way I can describe it. That's the best way I can describe it. Through the examples I'll be doing one of each. One prism, one cylinder, one pyramid, one cone. Maybe two prisms, because they do like to give triangle-based prisms, but when I go over the examples, you'll see what I mean. Hopefully, that height or distance between bases, okay? And then, so it's perimeter times height for a prism. The surface area of a prism, of course, SA stands for surface area, is perimeter times height, which is also our lateral area. So surface area, when we say total surface area, that's the lateral area plus the top and bottom. Alright? So that's where we add 2b. Now this is a capital B. Capital B equals area of base. So this requires that you're familiar with all the areas of shapes, trapezoids, triangles, polygons, kites, rhombuses, and squares. So we're familiar with those areas because that's what this is. We're going to have to find the area of the base. And of course, I'm going to go through some examples again. So I'm going to go over this again. Prism. Lateral area is perimeter times height. Surface area is perimeter times height plus 2b, where b is the area of the bases. Cylinder. Lateral area is 2 pi rh. R is just your radius. That's a common term. You guys should know that one. And then surface area is 2 pi rh plus 2 pi r squared. If you notice a cylinder, we already know what the area of that is. It's pi r squared. So just times by 2. Pyramid. Funny looking shape. Is 1/2 p times l, where l slant height. Okay? Of course, that's what that is. That's the side of our pyramid, or side of our cone. I'm going to go over some examples of how to do that again too. Again, at least what that looks like. Again, that's lowercase l. Surface area is 1/2 perimeter times l plus b, the area of the base of the pyramid. And then cone, of course you've seen this, pi r l. You should know what a cone is, hopefully. A traditional cone, where it's just going up. Pi r l. Then surface area is pi r l plus pi r squared. So, if you were taking notes and want to write down all this information, pause the video right now and do so, and then we'll be back with some examples. Okay, the first example I'm going to do is of a prism with a triangle base. I want to find lateral area and surface area. So lateral area, imagine you're looking at this triangle prism and it's got a round it. Okay. So what I like to do, level out everything that we need. We need the perimeter, and we also need the height. Now the height, I'm going to list that right out real quick. The height is the distance between the bases. As you can see, we have a triangle base. And how you can tell is there's only two triangles on our shape. So here's one triangle, and here's in the back is this other triangle. Of course, the dotted lines mean you cannot see the lines, but here's one base, here's other base. They're 10 feet apart. That's the height. So that means if you were to stand it up, it'd be 10 feet high, which 10 feet high. But that's the distance between the two bases. So our height is 10. Okay. Now perimeter, we need the perimeter of the base. All right. So not the perimeter of everything. We need the perimeter of this triangle. So if you need to, you can draw yourself a little base. That's the base. All right there. So we need this, which requires Pythagorean theorem. So I'm going to come over here and do all my work. A squared plus B squared equals C squared. So I got 5 squared plus 8 squared equals X squared. Because remember, hypotenuse is across from a right angle. So we get 25 plus 64 equals X squared. This may have been a 3, 4, 5 triangles. I never can remember them, so. Thinking it was? Actually, nope. So we get 89. Take the square root of that. So x equals 9.4. So that means this distance right here, this is 9.4. And since this is the same base, it doesn't matter. So perimeter equals 5 plus 8 plus 9.4. We get 22.4. Now plug those into this. We get 224. Oh, easy, right? That's the lateral area. And of course, this is feet squared. All right, so now we need to find surface area. If you look, we already have pH. We need capital B. Again, capital B is the area of our base. In this case, it's a triangle, so it's 1/2 base times height. Do not get this height confused with this height. This height only deals with your base, which is a 5 and 8 triangle. So 1/2, 8, 5 equals 20. Okay? Of course, we want 2 of them, so that means that just equals 40. It will end up being 40. So we come over here. We got 224. 224 plus 2 times 20. This equals 40. So this whole thing is going to equal 264 feet squared. Okay, so that's how you find the area of a triangle base. Next, sorry, I'm just going to check to make sure it's all in the picture. Okay, so and it's readable. It's not bad. All right, so next, let's do another shape. We already saw this. The next shape I want to find, I'm going to draw it first in case you're still writing down all that stuff. So the next shape I'm going to do is a square prism, rectangle prism. Okay. Some of the what I found. I'm just going to leave it up because I'm kind of finding the same stuff if you think about it. I have a list of variables that I need to find, and I'm just going to leave up what I need to find, what I need to labelize. So rectangle prism is kind of tricky because this area, surface area, is going to be the same no matter what you call your base. Because I have multiple objects with the same line. What I try to do when I am finding base, I want to make it simple. What is the only thing I have 2 of? That is, I have a 15 by 15 square, both two front and back. Because I could say I have a 15 by 32 rectangle and I have 4 of it. I could just take one across from each other as my bases. You're welcome to do that. Depends on what the book has lateral area. It depends if they signify what is the base. So for my purposes, my base is whatever I have 2 of. So my height is 32 because this is the distance between them. My perimeter, it's a square. It's a 15 by 15 square, so that means perimeter is 4 times 15, which is 60. So if I want to find my lateral area, 60 times 32 equals 190 20 centimeters squared. Alright? Moving along. See, it is pretty quick. Once you get the hang of it, hopefully it becomes quicker for you. Again, label everything out. Makes your life just a little bit easier. I need to find B. B in this case is a square. So the area of a square is S cubed, or S squared, sorry. Is S squared. That's a little small, sorry. It's S squared. So in this case it's going to be 15 squared, which is 225. So let's plug in our numbers. We got 1920 plus 2, and let's just go ahead and put a calculator. And we get a nice, 237 centimeters squared. So there is a surface area of 2 prisms, a triangle-based prism and a square-based prism. Sorry, let me do that way. Area is 2,370 centimeters squared. Let's do a cylinder now. Of course, you could get bases as hexagon and polygon, anything, any trapezoid, anything like that. Just need to recognize which one they are and use the appropriate formula. I did post a video, 11.4, on how to find the area of a polygon. So if you need a refresher on that, please go watch that one. So let's do one example of a cylinder. All right, so I'm going to erase all this. Cylinders are very fun to draw, I'll tell you. As you can tell, did not go to art school. Alright, so this is what we have for a cylinder. We want to find lateral area and surface area. Lateral area is 2 pi r h. If you notice the 2 pi r's, that's the circumference, the area around it. It's sort of like the perimeter. Okay? And then surface area, 2 pi r h plus 2 pi r squared. Alright, so signify what you have, signify what you need. We need an r. R, as you can see, our diameter is 4 whenever the line is 4, so that means our radius is 2. Our height, the distance between them, is 8.5. If you look, that's all I need. No, R is staying the same here, and H is staying there, so let's plug it in. I'm going to come down here, so 2 pi plug this into our calculator. I'm going to go ahead, I won't multiply by pi first. And they're all being multiplied together. So 34 pi, or you know, it doesn't hurt to put both answers. I like both answers. It doesn't hurt to put both. So surface area. Well, I already know what this answer is going to be, right? So 34 pi plus 2 pi 2 squared, right? So that means just 8, because 2 squared is 4, times 2 is going to be 8 pi. So 34 plus 8, 42 pi. Which also equals 131.95. Okay, and cylinders, we found the area again, so it's centimeters squared. All right, so that's how we find the area of the lateral area and surface area of a cylinder. Again, cylinders are actually pretty basic, pretty simple. Okay, so let's move on to pyramids and cones. Pyramids are tricky because they give lots of different bases, and we'll actually do one with the base. I'm actually going to end up doing a complicated pyramid to start off with, so I can show you all the tricks and all what you need to know how to start off with. Okay. So we're going to start off with that one, and then we'll do a cone the same way, and then show that maybe you don't need all this stuff. All right. So let's go ahead. Make sure I get the formulas right, and let's start. All right, so. So let's pyramid. We're going to do a Pentagon-based pyramid. Just letting you know, my drawing is going to be horrid. It's going to be horrible. So let's do it anyways. I mean, why not? Okay. And this will be nice because we also need to find the lateral area of it, given certain aspects. So I'll actually probably end up doing 2 pyramids for you guys. So let's draw. I'm going to draw my pentagon first. Again, it's not the best of pyramids. I did not. Just trying to get through it quick. Okay. Let me use a different color. Hopefully it shows up. It works. There we go. That is my height of the pyramid. Okay, so base is 10 centimeters. Height is 9, or sorry, not centimeters, meters. 10 meters, 9 meters. All right. So let's go ahead and find the lateral area and surface area of this. Again, lateral area of a pyramid is perimeter L, or sorry, 1/2 perimeter L, and surface area plus base. All right, so we got a lot of stuff to find here if we think about it. First one is we need to find the perimeter and at L, and while we're at it, we need to find capital B. Right? All the stuff we need to find. Actually, no. Oh, leave it back up here. Okay. From it, came from here to the top. That is not this. That is its altitude, how tall it is, not the L. Okay, so L is slant height, so if it was coming up at an angle. So what we need to do, imagine then, that this is what we have. We need to find this. Sorry, let's not go little x. We need to find that, and this is what we have. Okay, so we need this length, which, that's a pentagon. So I'm going to come over here. Again, I'm kind of all over the place. Hopefully you can follow along. But in my pentagon, I suck at drawing pentagons. In my pentagon, I'm told that this is 10. It's your other pentagon, okay? So I need to find this height, because that relates to this. That's the apothem. If you remember from 11.4, that's the apothem. And if you think about it, we need to find the apothem anyways, because we need B, where B is the area of the pentagon, and that's 1/2 AP. Told you I was going to do a complicated one, so here's a complicated one. And all we're given, we have a triangle, we have this, which we have another triangle, you know, if you guys remember. We need to do all this stuff, okay? It's pretty, so again, if you need a refresher on how to find the area of a polygon, go watch 11.4, go redo it, whatever. Which, but let's get going on it, okay? So this is also A. All right, I'm going to find this first, because it's going to lead to all that. To find this, hopefully we remember we need P, N, S, A, theta, which is 360 over N. All right, perimeter of the pentagon. Nice. What's nice about this P and this P are the same. All right, N, we have five number of sides. 5. S, our side length, which is 10. Our theta, 360 divided by 5, 72. Okay, look in. Let me make sure I got all this on the board. Yay, I do. Or all in the picture. All right, so we need to find A. Perimeter is easy, that's 50. Right? Because length, or it's N times S, so it's 50. All right, so I can go ahead and put 50 here. All right, so let's find our A. Remember, this 72 is that whole angle right there. Cut it in half. That means this is 36. All right, so we need to find this. That means also this, remember that line, if you remember that line cuts it in half. So this is 5. We need to find A. Use our trig. Tangent of 36 equals opposite over adjacent. 5 over A. So A equals 5. Tangent 36. 5 divided by tangent 36. We get this is equal to 6. So it's 6.88. That's our apothem. That goes here. All right, so that means that comes over here. To find L, it's a right triangle. Okay, because remember, that's this, all right? Or sorry, let's go like this. That's this, and what we want to find, hopefully, orange shows up for you guys. We want to find that. This little orange line, that's our L. Okay? See, it's on the side of it. Okay, so that means we need to go 9 squared plus 6.8. 8 squared equals L squared. So 9 squared plus, get 128.34, or sorry, just 0.33. Take the square root of that, and I get L equals 11.33. Man, we did a lot of work. We still haven't got an answer yet, but we're close. Because now we just need to plug this times this, and then take half of it to get our L, to get our lateral area. So, times that by 50, divided by 2. 283.2, that's our lateral area. Alright. Let's go ahead and find this number, because we need that, because we're going to add this to that. Okay? So 6.88 times 50, divide that by 2. This is 172. So if we add them together, this answer equals that. A lot of work. It's a complicated pyramid. Pyramids are kind of complicated because you need to remember all your stuff. Area, polygon, as you see I did all that on the side. And then I relate that to a triangle, which I have to use Pythagorean theorem to get all the answers, all for two little things. Surface area and lateral area are kind of a complicated section. Let me do one more pyramid that is another complicated one in terms of, not in terms of area, but in terms of how it looks, based off the information they give you. Because there's something it's really hard to explain without seeing an image of it or an example. So, this pyramid, we have a square. It's decent. I'm going to use blue for the height. Hopefully you guys are able to see it again. Again, this is the altitude. Has nothing to do with our formula, but it does help us find what we need. This is 12. Okay. And 14. And again, our lateral area, where'd my orange go? Our slant height is that. We need to find that distance, okay? So, lateral area, 1/2 perimeter L, surface area, (1/2 perimeter L plus B. Okay, so let's go ahead and plug in what we need there. It's a square base. I know it doesn't look like it, but it's a square base. So a perimeter is 14 times 4. Just cover that there. 56. Okay, so what we need to find is our L, our small L, our slant height. Okay. How to do that? If we look, we have a triangle. 12. This is the tricky part about pyramids and cones, but pyramids mostly. This right here, this distance, because on the previous example was the apothic. This time it's a square base. All right, that means this is 14, and 14 that cuts that in half. All right, so this length is 7. All right, so that means this is 7. All right, this is L. So again, it's a square base. That length cuts that square in half. All right, so you can do the apothem stuff if you want to check it. I believe it should be 7 if I come out and do all the math right. So we get 12 squared. If I'm wrong, let me know. Plus 7 squared is 193. Take the square root of that. And I get 13.89. Okay. I need to find capital B. So it's a square base, so it's just 14 squared. $196. So I got my P, got my L, got my B. Just plug everything in now. So 1/2 is 0.5 times 56 times 13.89. This is 388.92. We're going to go ahead and add that to 196. So this is 584.92. So 2 examples how to find the area of a pyramids. Okay. They are one of the more complicated ones. It seems prisms and pyramids are complicated. While cones, on the other hand, pretty simple. So we're going to do one example of a cone and see how you guys do that. You notice I've used Pythagorean theorem almost every time. It's a common theme. They give you the height or altitude. You use Pythagorean theorem. But let's take a break from that. So this is what we're given. This is the kind of cone we're talking about. All right. We're told this is 21. This is 8. And it goes ahead and shows us this dotted line. Again, that dotted line is your altitude and height. Usually they'll give you that. They'll give you that, and this, and you got to find your radius, Pythagorean theorem. This or this, you need to find your L, Pythagorean theorem. Not going to need to do Pythagorean theorem here because lateral area for a cylinder is pi RL, and surface area for a cylinder pi r L plus pi r squared. So label what we have. Again, I like labeling it out. That way you know what you have, you know what you need to go find. R is 8. L is 21. Okay, again, I like it. It makes it easier so you know what you need to go find. So it means we get pi times 8 times 21. So get 168 pi, or about 527 78. All right, so we need to find this one now. We already know this is 168 pi plus pi 8 squared, which is 64 pi. This equals 232 pi, which equals 728.85. So there's your answers for our cylinder. Cylinder is actually one of the more easier ones compared to pyramids. So as you noticed, with surface area, there's a lot going on. Surface area and lateral area, there's a lot going on. Out of the easy ones, cylinders and cones are probably the most easiest because it deals with circles as your base and your radius. Pyramids or prisms would probably be next. Identifying your base is one of the hardest parts about prisms. And then with pyramids, depending on your base, it can be more complicated. There's a lot more going on to find the surface area and lateral area of a pyramid. So there's all 4 lateral areas of 4 objects.